What is up, team? I am the Master's Math Teacher, and in this video we will be exploring the concept of interval notation and how that relates to set notation. So jump on board and let's get into it. So similar to sets, intervals are a different way of representing regions of numbers. Intervals are generally easier to write and hence they are used rather than set notation when dealing with graphs. However, it's good to know how to do both because both come up in tests and exams. So let's take a look at a region. We've got a number line here. Let's take a look at the region from -3 all the way up to 4. Okay, so when we are looking at this, if you recall from earlier years in high school, you might remember how to write it using less than or equal to symbols. So let's take a look at that. What is the biggest number x can be here? So we're going to let x be the numbers in this bar. The biggest number x can be is 4. So we know that x has to be less than 4. And the smallest number x can be here is -3. So we know that it is greater than -3. So this is how we would write that using just less than, equal to, those sort of symbols. So now let's put that into some interval notation. Now interval notation uses one of two brackets, either a circle bracket or a square bracket. And the difference is, a circle bracket is when it's less than or greater than, not equal to. A square bracket is when it's less than or equal to, or greater than or equal to. So in this scenario, because we had a hollow circle, so this is also an interesting point to note, a hollow circle is what's used to represent a circle bracket. We also have a square bracket, which is represented by a solid circle. So for this example here, we would actually say the interval is circle bracket, -3 to 4 with another circle bracket because we're not equal to either of them. Now in interval notation, we always have the smallest number first. Smallest first. Okay. Now we could also write that in set notation, and this might come up in your books a little bit. What they do is they write it like this. X such that, that's what this symbol means such that, -3, x, 4. So that is the same thing, okay? So this is where we're trying to link set notation to interval notation. And that's why I prefer interval notation, because I find it looks a bit easier and it's a lot easier to write. But it's really important that you understand how to read both. So let's do some more examples with this. We need to build up some more examples so that we understand how this works. Let's go with a -5. I'm going to draw a solid dot here now. And we'll end at 2 with a hollow dot. So let's see. We'd have, for set notation, squiggly bracket, x such that, we've got -5 as the lowest. We know that x is greater than that, but it's also greater than or equal to that. But we know it's only less than, not less than or equal to, 2. Okay, that's our set notation. This is the same as writing smallest number first, which is -5, comma, the biggest number, 2. And then we have to decide which bracket should we use. Well, we've got a solid dot for our -5, so we're going to use a square bracket because we actually reach -5. We have a hollow dot at 2, which means we get really, really close to 2, all the way up to 1.999999 recurring, but we never actually reach 2. So we put a circle bracket there. Okay, so that's what that represents. We're going from 5, and we reach 5, sorry, negative 5, all the way up to 2, but we don't reach 2. Let's do another one. Let's go this time from negative 4, and I'll put a hollow dot there, and this time we'll go all the way up to 7, and I'll put a solid dot up here. So, let's have a think. Let's do interval notation first this time. We write the lowest number first, negative 4, comma, the largest number, 7. At the negative 4, we don't reach it because it's a hollow dot, so we're going to put a circle bracket. At 7, we have a solid dot, so we are going to put a square bracket. Now let's see how to write that in set notation as well. We always write x such that. Now for these examples, I'm only using the variable x, and most cases they will also use the variable x. However, sometimes they may use something else, and that's absolutely fine too. So we've got x such that, that's what the double dots mean. Negative 4, x is greater than negative 4, but less than or equal to 7. And again, we're using squiggly brackets because of course we're dealing with set notation for that example. To pause the video and see if you can work this one out yourselves to start with. I'm going to go from there to there. That's at 1. Give it a moment, think about it, see if you can write it down. Alright, so let's do interval notation first. We're starting at negative 6, the lowest number. We're going to 1. We have a hollow dot at negative 6, so a circle bracket, and a hollow dot at 1, so another circle bracket. Let's try it in set notation. X such that negative 6, so x is greater than negative 6, but less than 1. Close the set notation. Let's do one other example like this, because there's one more that needs to be done. You might be able to guess it. It's where we have 2 solid dots. Let's do a really small one here. Again, pause the video for a quick moment and see if you can get it. Alright, so we have first number, negative 4. Second number, negative 2. Solid dots, but both of them, so square brackets. And in set notation, let's have a look. We're going to have x such that we've got greater than negative 4, greater than or equal to this time, because again, solid dot, x, which is less than or equal to negative 2. Now, all these examples have been bounded intervals, okay? So they've been between 2 points. But what if it isn't bounded? What if we didn't start and end at a point? What if we, say, went from here, hollow dot, and we actually just went on, so with an arrow? So how would we write that with set notation? We're going to do set notation first this time. We've got x such that, and we're looking for just x is less than negative 3. So I'm going to write x less than negative 3. And I didn't use less than or equal to because I've got a hollow dot there. So how would we write that with interval notation? Well, we know the biggest number is negative 3. And we know that it's got a circle. So what do you think the lowest number will be? Where does it go? Now you might be thinking, well, it doesn't have an end, and that's exactly correct, because it goes all the way down to negative infinity, and it never stops. Okay, so even though there's no bottom number here, we could have actually written that as greater than negative infinity. However, we don't need to. With set notation, we don't need to. In interval notation, we do. And when we're dealing with infinities, we always use a circle bracket. We can never reach infinity. No matter what you try to do, we will never reach infinity. Okay, let's do another example like that. I got my number line. And this time I'm going to go from a solid dot here, that way. Pause the video and give it a shot. All right, so our smallest number is 3. It's a square bracket because it's a solid dot. And our largest number is infinity because we go on forever. And we always put a circle bracket there. In set notation, we have x such that, and we can actually just say x is greater than 3. Again, we could write less than infinity, but we do not have to. We can just write x greater than 3. And don't forget your equal to, because of course it's a solid. And then we close the squiggly bracket. Now there's a few more things to cover when it comes to interval notation. One of these is when we link some of our strategies used in the last section, and that was with our set notation. So what if I had a line that looked like this? I start here with a hollow dot. I go to here with a solid dot. And I'm going to call this line A. Okay, this is the set A. And in a different color, I'm going to go from here with a solid dot to here with a hollow dot. Make that a little bit more hollow. So what if I said, and I'll call that B, sorry. I'll call that B. So what if I said, what is the set of A? Or what is the interval for A? So the interval for A, we're going to write -5, circle bracket, goes to -1, and it's a square bracket. B, we're going to write -2 with a square bracket to 3 with a circle bracket. Now what if I asked A union with B? Pause the video and give it a thought. So if we've got A union with B, so we've got the two intervals here. Remember, union means everything they all have. So when you add them together, you mix them up. So we've got, it goes from -5, -4, -3, -2, -1. But B also contains 0, 1, 2, and 3. So this actually goes all the way from -5 with a circle bracket, because neither of them contain this, all the way to 3. And again with a circle bracket. That is the union of them both, where they both go all together. So what about the intersection? So we've got A intersect with B. Again, pause the video and give it some thought. So when we're dealing with the intersection, you could just look at the intervals and see if you can figure it out. However, if we have it on our number line, you can draw a little line here and see where the intersection is based on the endpoints. So we can see here the B starts at -2 and it hits A at -2, which is good. So the starting point of this intersection is -2. And of course, both of them actually reach -2, so it's all good. It's a square bracket. Now A ends at -1, which is also where it intersects B, so it goes to -1. And again, it's a square bracket because at least one of them has hit that point. So that's how we link using our interval notation with our set notation. Now, the last thing I want to cover is the set of all real numbers. That's denoted like this. Now, in some textbooks, you might see it bolded because they can't write the double line. You might see it in a funny font. But essentially, this means the real number line. The real numbers. And that means that it goes from negative infinity all the way up to infinity. So it's everything, all the real numbers. There's also something called real positive. So it's just reals with a little plus on top. And that is real positive. Now, something that's very important to note, the real positives go from 0 to infinity, but they don't include 0. It does not include 0. Reals include 0, but real positive do not. You can also do real negatives. Which again, this time it ends at 0 and goes to negative infinity, but it still does not include 0. Okay? The reals include 0, but real positive and real negative do not include 0. If you wanted to say, write this interval from 0 to infinity with a square bracket because you want to include 0, to write that in set notation, you can actually write real positive in union with the set 0. Okay, because that is now in union with the number 0. So that's something interesting and something very important to note, because that will also come up in some of the questions. Well done on making it to the end of the video. Hopefully it helped explain some of the weird concepts around interval notation and how that links to the symbols learnt previously in set notation. So that's all from me. I'd like to say good luck, but you don't need it. Go smash out some maths. If this video helped, leave a like. If it didn't, leave a dislike and let me know in the comments what I can do better for the next time. And if there's a topic you want me to cover, let me know.